So we're going to talk about symbols and sets of numbers, obviously, and sets of numbers, there are quite a few. Let's start off with a really basic set of numbers. First of all, the way you write a set of numbers is using these curly parentheses here, and if my set of numbers is all these, 1, 2, 3, 4, 5, 6, etc., to infinity and beyond, that set of numbers is called natural numbers. You may, back in the day, have heard these referred to as counting numbers. That set is called the set of natural numbers. And so each number in that set is called an element of the set. You could maybe refer to this as a member of the set. Each thing in the set is called an element or a member of the set. So that's a set called natural numbers. It's positive numbers, whole numbers, going from 1 to infinity. There's another set of numbers very similar to this one. In fact, it looks exactly the same, except it doesn't start with 1. It starts with 0, etc., all the way up to infinity. And that set you're probably more familiar with. That's called whole numbers. The implication, of course, being that 0 is unnatural. 0 is not in the set of natural numbers. 0 is in the set of whole numbers. So we are eventually going to add in a few more sets this evening, but that's a good starting place, natural numbers and whole numbers. The only difference between the two is that whole numbers has 0 in it and natural numbers do not. Do you have any idea what the 3 dots on the end mean? Exactly right. That's the math way of saying etc. Keeps on going forever and ever and ever. Okay, so we're going to start off with these two sets, and we're going to add in a handful of symbols here. So the symbols that I'm going to list for you are called equality or inequality symbols. And I bet you know one of them. But you know everybody's favorite. What symbol is that? That's equal to, is equal to. So we'd read this as A is equal to B. Equal to symbol, not too bad. Have you seen this one before? Is not equal to. A is not equal to B. How about this one? You seen that guy? Greater. What was your second choice? A is less than. So one of the ways you can remember this is if you think of this as like an arrow. It's not an arrow, but think of it like it's an arrow. This arrow is pointing to the left. Less than points to the left. They both start with the letter L. Less than points to the left. Okay. What about this? Greater than? That's greater than. So this would be A is greater than. Now, when you learned this way back in the day, you might have had a teacher that tried to get cute with you. That was like, "Oh, it's the crocodile eating the big one," or whatever. Actually, forget it. What
I always thought was you could almost make a G out of that symbol.
Oh, you could make a G out of the symbol? Man, that is quite a stretch. Less than looks like an L. So regardless of the method you learned it originally, I just want you to remember this one's less than and this one's greater than. If you remember less than always points in this direction, then you don't have to worry when you read it, am I reading it the correct way? Less than, greater than, whatever. Just remember less than points in that direction. Okay? How about this guy?
Greater, less than, equal to?
Good. A is less than or equal to. And then finally, what do you suppose that is? Good. A is greater than or equal to B. Whew, man, that's a lot of symbols. So far, so good? Yes? Okay. I will take your silence as a Yahoo. So I'm going to give you a few statements. And all I want you to tell me for these statements is, are they true or are they false? Statement number 1. Scoring 3 points in a Super Bowl is a totally normal thing for the second highest offense in the NFL to do.
False.
False, thank you. Number 2. True or false? Now, before you answer, can someone say that out loud? How do you read that?
2 is less than 3.
Very good. 2 is less than 3. True or false?
True.
Yeah, it's true. As it turns out, 2 is less than 3. Okay? How do you say that out loud?
72 is less than 27.
Very good. 72 is less than 27. True or false? False. Okay, great. Let's try another one. How do you say it?
8 is greater than or equal to 8.
Yeah, 8 is greater than or equal to 8. True or false?
True.
That's true. It's not greater than, but it is equal to. So this is true. Good. Oh yeah, well what about this one then?
True.
8 is
Less than or equal
less than or equal
to 8.
to 8. That one's also true. Not because of the less than symbol, but because of the or equal to part. Okay.
Twenty-three is
23 is less
less than or equal to 0.
than or equal to 0. That's correct. Is this a true statement or a false statement? False. 23 is not less than or equal to 0. Okay, let's do one more. How do you say it?
Is less than equal to 23.
0 is less than or equal to 23. True or false?
True.
0 is less than 23. That's true. All right. Let's try to go the other way. Let me give you the words. I'm going to actually write it out in words, and I want to see if you can write it in symbols. 9 is less than or equal to 11. What comes first? 9, the digit 9. Then what? Less than, which one's that? Huh?
One that points to the left.
The one that points to the left.
The equal sign, equal to the bottom.
Yep. Good. Eight is greater than 1.
Greater than symbol,
Good. Greater than is the one that
goes to the left. Opens left.
opens left. Good.
The one.
No equal to line on that one, right? It's not greater than or equal to, it's just greater than. How about this one? The digit 3. Equal sign with the line through it. 4. 3 is not equal to 4. Now, all of these statements that I've given you so far using these symbols have been numbers from one of those two sets we talked about, the set of natural numbers or the set of whole numbers. Okay, so let's add in another set of numbers. Let's make these a little more complicated. Okay. So this is the set of whole numbers plus all the negative whole numbers. You know what this set is called?
Negative integers.
It's integers, not negative integers, just integers. Integers automatically includes the negatives. Integers. So what are integers good for? Well, most recently they've been good for the weather. I don't know if you guys know, it's been kind of cold recently. I was watching the weather report and they said that in the city of Chicago, the wind chill was 50 degrees below zero. It's really crazy. The wind chill, with the wind chill, it was 50 degrees below zero. In Antarctica, it was 7. So Chicago was colder than Antarctica. So if I said 50 degrees below zero, what is the integer that would represent that number? Negative 50. That would be the temperature. Negative 50 Fahrenheit, because this is America. Crazy. You know, people give us Texans a hard time. Like, oh, it's so hot in Texas, but nobody's freezing to their sidewalks down here.
Or slipping.
Our shoes might be melting to the sidewalk, but we're not slipping or freezing to them. Okay, let's do another set. This is going to look weird.
Wait, what's an integer again?
Good question. Oh, this is the part where somebody in the class explains what an integer is.
Positive and negative numbers.
Yep, all positive and negative whole numbers. That's what integers are. This set is called rational numbers. I think the easiest way to explain what a rational number is that it's a fraction. Rational numbers are fractions. Notice that it says a and b are integers, which means the fraction could be positive or negative. And b does not equal 0. Why is it important that we say b does not equal 0? Why is that a requirement? Why do we have to specify that b does not equal 0? What would be so wrong with b equaling 0?
Isn't well, this depend on the fraction, I guess. When it's always 0 with this in the denominator, right?
Oh, is that true? Does the fraction equal
so.
0 if the denominator is 0?
Yeah, isn't that true?
I don't know. What's everybody else think?
You have like integer that integers always equal 1.
We have 0 in our integer set, right? 0 could be an integer. So when we say they could be integers, we're saying a could be 0, but then we specifically say b can't be 0. That seems weird. If a was 0, if the numerator was 0, the value of the entire fraction is 0.
Right.
If b equals 0, the value of the fraction is undefined. You cannot divide by 0, and a fraction is a division problem. When you do a divided by b, you're saying the number a divided by the number b. You cannot divide by 0. Try it on your calculator. It'll give you an error. It'll say can't be done. It can't divide by 0. My mom, when she was teaching me math, explained it to me like this. She would say a is how many cupcakes there are, and b is how many people there are. If you have 0 cupcakes and you divide them amongst 10 people, everybody gets 0 cupcakes, right? There aren't any cupcakes and you divide them amongst 10 people. But if you flip it, if I say there are 10 cupcakes and 0 people, and I say how many cupcakes does everybody get, that question doesn't make sense. How many cupcakes does everybody get? There are 10 cupcakes, but who's the everybody? There are no people. It's just 10 cupcakes. There's nobody to divide them amongst. So the question, how many does each person get, doesn't make sense. Long story short.
Would we have to put that in the homework?
No.
Does
The
it
answer.
make sense?
The answer is undefined.
Okay.
If b is 0, it's undefined. The hardest part of these rational numbers is actually putting them in order. So I'm going to create a number line here. I'm going to create a number line that goes from -5 to +5. Okay, and I'm going to give you a set of numbers here. And we're going to try to put these numbers in the correct spot on the number line. So out of all the numbers that I just gave you, which one do you think is the easiest to put in the correct spot?
3.5.
I agree. 3.5 is really easy to wrap your head around. On the number line, 3.5 is exactly in the middle between 3 and 4. So this guy is going to go right here. There's 3.5. Okay, what else you got?
Quarter.
Oh, a quarter. That's pretty good. Where should that go?
Should go between 1 and 2, but more to the...
Between 1 and 2?
Excuse me, 0 and 1.
Between 0 and 1, but more towards...
0.
Right, because here, right in the middle would be a half, right? And a quarter is half of that. So like right about there is where we put 1/4. That seems good.
And then negative 3, or no. Negative 2 and 1/8, no.
The negatives get a little tricky, so let's do our last positive one, which was 3/2. How much is 3/2?
2 and 3 is
Let's back up. How much would 2/2 be? If instead of 3/2, this was 2/2, how much would that one be?
1.
2/2 would be 1. So 3/2 is going to be a little bit higher than 1, right? So here's 1. It's going to be higher than 1. Is it going to be higher than 2? Why not?
Because there's not 4.
Yeah, good, good. 4/2, 4/2 would be 2. So this, I'm just going to write this here. 1 would be 2/2, and 2 would be 4/2. So 3/2 is exactly in the middle. Right there. Okay? All right, let's tackle the negatives. Negative 2 and 1/8 is actually one of the easier ones. Negative 2 and 1/8.
Would it be like negative 17/8?
Yes, if I wanted to convert it into an improper fraction, it'd be negative 17/8. I don't know that makes the problem easier.
Does it?
Think about negative 2, though. If I was at 0, I counted down. Here's negative 1, here's negative 2, negative 3. Negative 2 and 1/8 is just a little bit more than negative 2. So I go negative 1, negative 2, and just a little bit more than negative 2. That's where I would put negative 2 and 1/8.
kind of like a measuring tape.
It's exactly like a measuring tape. What about negative 4/3? Well, let's do an easy one. What would negative 3/3 be? That'd be negative 1, right? This is negative 3/3. What about 2? How many thirds would 2 be? 6. Yeah, so this would be negative 6/3. So negative 4/3 is in between these two, but not exactly in between these two. It's closer to the negative 1. So like right there. Negative 4/3 is actually negative 1 and 1/3 if you turned that into a mixed number. Negative 1 and 1/3.
And negative 3 would be like 9/3, right?
Negative 3 would be, yes, negative 9/3. Yes. All right. Feeling all right so far? Yeah. Let's add a couple more sets. Okay. This set is more words. Non-rational numbers that correspond to points on a number line. That is quite a hefty set there. This is the set of irrational numbers. So the most famous of the irrational numbers is this guy. Pi, which is 3.141596, etc. Another really common irrational number is the square root of 2, which is 1.41 something. Those are examples of irrational numbers. Now notice it says non-rational numbers that correspond to points on a number line, meaning it does not fit inside the rational numbers group, and here's why. Rational and irrational numbers both can be written as fractions. So rational and irrational can both be written as fractions. So what's the difference? Rational numbers terminate or repeat. Now what do I mean by that? 3/4 is an example of a rational number because if I do 3 divided by 4 on my calculator, I get 0.75. That number stops. It doesn't keep going after the 0.75. It's 0.75, done. Another example would be 2/3. If I do 2/3 on my calculator, it's 0.6666666. It repeats. It's the same thing over and over and over again. That is a rational number. Irrational numbers don't do that. Pi is a decimal that goes on forever and does not repeat ever, and it doesn't terminate. Same thing with the square root of 2. The square root of 2 does not repeat and it does not terminate. That's irrational. So rationals, when you divide them out and get a decimal, they either terminate or they have a pattern. They repeat. And the final set, everybody's favorite, all numbers that correspond to points on a number line. And this is the set of real numbers. Now, when you write down the phrase real numbers, you might think to yourself, wait a second, Taylor. You trying to tell me that there's such a thing as numbers that aren't real numbers? And the answer is yes. There is such a thing as numbers that aren't real numbers. They are called imaginary numbers. You will not have to deal with non-real numbers in this semester, but in the next semester you will. So that is either something to look forward to or something to spend every waking hour dreading for the rest of eternity. Up to you. So I want to make a flow chart for you here of how these sets all relate to each other. So up at the top of the chart, we are going to write real numbers. Okay, real numbers is any number you can put on a number line. So like negative whole numbers, negative fractions. We got 0 included in there. You got your irrationals like the square root of 2 and pi. And you got rationals like 47/10. Okay, these are all in the real numbers category. Every number you're going to deal with in this semester falls into the category of real numbers. Now, from real numbers, we branch into two different sets of numbers branching off from real. One of those sets is irrational numbers. And irrational numbers are things like pi and the square root of 2. The other branch is rational numbers. Which is all the stuff that isn't irrational. So like negative whole numbers are fine. Negative repeating fractions are fine. We still got zero, whole numbers, positive fractions with a pattern. All these things fall into the rational numbers category. Rational numbers also split into two different groups. Rational numbers split into integers and non-integers. So an example of a non-integer would be fractions. And an example of integers would be whole numbers. Zeros included, positive numbers, negative numbers. Those are integers. Okay, then integers is split into two groups. There's the group of negatives, or negative integers. That'd be stuff like negative 20, negative 13, negative 1. And also whole numbers. Which is exactly what you would expect. And then whole numbers is split into two groups. One of them's really easy. One of the groups is called 0. There's only one thing in that set. It's 0. You know what the other set's called? The whole numbers except for 0? Naturals. Natural numbers. And then 0 is split into two. I'm just kidding. No, dang. That thing is so dramatic, we can't even fit it all on the screen at once. So if I were to tell you something is in the group real numbers, I have a number that's in the real numbers group, I could be talking about anything. If I tell you I have a whole number, this is a whole number, that means a whole number means it's also an integer, and it's also a rational number, and it's also a real number if it's in the whole number group, but it's not necessarily a natural number. Okay? If I told you something was in the non-integers group, it is also in the rational numbers group and also in the real numbers group. So every number you can think of at this point in your life falls into the real numbers group. If you can think of it, it's in the real numbers group. Next semester, I'll give you something to think of that aren't in the real numbers group. But for now, literally any number you can think of is a real number. Okay, so we good here?
Sure.
Sure. Let's mix our groups. Of those symbols we did, equal to, less than, greater than, etc., those symbols, which one should go in between those two numbers?
-5 is less than -6. Right? Oh, what group? Like
No, what symbol? Is -5 less than -6?
No.
It's greater than.
Negative 5 is bigger than negative 6. 5 is bigger than 5. If it was just 5, 5 is smaller than 6. But negative 5 is bigger than 6. Which one's colder, negative 5 degrees or negative 6 degrees? Negative 6 is colder. What should we put there? Less than, greater than? 3.195 is less than. Good. All right, let's get real tricky. See if I can really bake your noodle. Which one's bigger, a fourth or a third?
No, maybe a third's bigger.
A third's bigger than a fourth. So which symbol do I put in the middle?
Third's bigger, so it's less.
So less than. Good. I'll give you a set of numbers here. Question number 1. From that list that I gave you, which are the natural numbers?
11.
11's a natural number?
112.
And 112 is a natural number. Great.
Should we write this down?
Hmm?
Should we write this down?
That's up to you. Which ones are the whole numbers?
Zero.
0.
And 11, 12.
Good. Which ones are the integers?
Zero.
0. 112. Good. Okay, good. Which ones are the rationals? 1/4. Square root of 2.
Wait, I thought square root of 2 was a
Yeah,
rational
it's
number.
zero.
Oh.
Oh.
0 is, yep.
So everything except square root of 2.
Yeah, everything except square root of 2. What are the irrationals?
Square root of 2.
Square root of 2?
Everything else.
And that's it, right? Just square root of 2. Which ones are real?
All of them.
All of them.